Hello, everybody. So, yesterday we talked about the historical perspective of motion and forces and the Aristotelian viewpoint of things, and how that led them to try to say that the Earth moved around the sun instead of that the sun moved around the Earth rather than the Earth moving around the sun. And that was the Copernican viewpoint, which was supported by Galileo Galilei. Right? And so in class, you saw a couple of demonstrations that mimicked some things in the movie, which I can't show you now for copyright reasons, but that we watched in class. And hopefully those demos in that movie can convince you that Galileo came up with a way to explain how we could be on a moving Earth. And that's an idea he called inertia. Now, inertia is a property of matter. Things that have mass have inertia. In fact, we often use mass as a measurement of inertia. Okay, so things that have more mass have more inertia. What is it? It's a property of matter. It's a tendency of an object to continue doing what it's doing. Right? Things that are at rest tend to stay at rest. Things that are moving tend to keep moving, but not just any motion. They tend to move with constant velocity. And so that's kind of the more generic way of saying it. Objects at rest tend to stay at rest. Objects in motion tend to stay in motion at constant velocity. And so we could be on a moving Earth because we're moving right along with the Earth. And in fact, there's not even any air resistance or anything because the atmosphere moves right along with us. And since there's nothing to hold us back, we can move right along with it. And we've got a lot of experience with that, flying in planes, driving in cars. I mean, if you're driving down the highway at a constant velocity and you throw something up in the air, you don't expect it to go smashing into the back windshield. You expect it to go up and come right back down, right? Because it's moving right along with the car. It has inertia. So again, this is how we could explain this, and as you saw in the movie, it created tremendous issues for Galileo Galilei. Well, that moves on to the next guy. And this is kind of interesting. Look at his date of birth, 1564, and when he died, 1642. The very same year he died, Sir Isaac Newton was born, 1642. It's kind of interesting. Some people have said, maybe there could only be one mind like this at a time around the world. But the other cool thing about Isaac Newton's birth is that it was Christmas. Now, if you look this up on Wikipedia or Google it or something like that, they may give a different day. And that's because at the time that Sir Isaac Newton was born, they weren't using the Gregorian calendar yet. They were using the Julian calendar. And the Gregorian calendar changed that day. And so if you follow through with it, it's not December 25th. But it was December 25th in England when Newton was born. They were celebrating Christmas, so I like that. So I'm going to use December 25th, the same year that Isaac Newton was born. And so Galileo died is the year that Isaac Newton was born. And so we'll talk more about some of the crazy things about this guy, but he came up with 3 laws of motion, and in this unit we're going to look at the first law of motion. His classic way of saying it is that an object will continue in its same state of motion unless acted upon by a net force. And so he's saying, in other words, things have inertia. They're going to keep doing what they were doing unless there's a net force. What's a net force? Technical math, vector sum of the forces. We've done vector summing. We've added vectors, right? We drew all the vector diagrams last unit. And so this is what would be left over, right? The stuff that doesn't get canceled out when you add them all up. Okay? And we'll practice that more in this unit. Or as we found the other day, objects move with constant velocity when the forces are balanced. When the forces are unbalanced, they move with changing velocity. This is our way of discovering Newton's first law. Okay? So again, constant velocity, balanced forces. Unbalanced forces, velocity changes. And we'll talk more about how much does the velocity change and why and all that in another unit. Okay? But for now, we're going to look at cases, constant velocity means the forces get balanced. So this is Isaac Newton's first law of motion.